Yesterday we learned a law of exponent that says when you multiply, you had to keep the base and do what to your exponents? Add them. Okay, today we're going to expand upon that, and we have a power rule, it's called. Turn around. There's nothing recording besides you looking like a fool to the rest of your class. Okay? A power to a power means that you have an exponent on an exponent. For example, 2 to the third squared to the fourth. So if we go to the inside of this first, 2 to the third squared means we have 2 to the third times 2 to the third. Follow me? We have 2 to the thirds. Yesterday, you guys learned that when you multiply, you keep the base and you add the exponent. So what's the base we keep? 2, and we'd add 3 plus 3 to give us 2 to the sixth. But really, I have a fourth power out there. So I have a 2 to the sixth, 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 which is really 2 to the 24th. I don't know about you guys, but I like to be lazy. I don't want to do this. Mason? Multiply them. When you have an exponent on an exponent, a power to a power, you multiply. So go to the right. What's the base I'm going to keep? 7. I'm going to multiply 3 times 4 times 3. 3 times 4 times 3. 36. I know yesterday was very easy, okay? I know that. Today I'm adding a new rule, and you're going to see both of them come into play today, and you have to be able to differentiate what rule do I use and when. All right? One thing here, if an exponent is outside the parentheses, it's like kind of like distribution, it has to be shared to everything on the inside. So in this case, my exponent of 3 needs to be shared with every separate piece. 2 to the third, y to the third, and z squared to the third. That 2, oh God, what's the name of that? It's like a vocab word. The number out front. Coefficient, very good. When you're dealing with a coefficient, we're actually going to calculate what this is. Now listen carefully. 2 times 2, 4 times 2, 8. I'm actually going to calculate this because it's the coefficient in a monomial. Unlike up here, I don't really want to know what 2 to the 24th is. Follow me? Okay? Okay, so we have 8. Then I, just like yesterday, keep the base. What's my first base? Y. And I need to multiply my exponents. Mason told me to multiply my exponents, but Miss Hoff, I only have one exponent. Technically, there's a 1 there, right? So I really have 1 times 3. What's the next base I need to keep? Z. And what am I going to multiply? 2 times 3. So my final answer would be 8 y to the z to the 6th. Try the one on your right. Negative 2xy cubed raised to the 5th. Some of you learned last Friday that a calculator can almost be more painful to you than helpful with negatives and exponents, yes? So when I share that 5, notice how I put my negative 2 in parentheses. So that means both my 2 and my negative is going to be repeated 5 times. Is my final answer positive or negative? Negative, because there's an odd guy out, right? Now, you really, in this case, don't need a calculator. We need 5 of them. 2 times 2 times 2. Let's start over. 2 times 2 times 2 times 2 times 2. 32. So you have negative 32. Keep your base. What's your base? What exponents are you multiplying? 1 times 5. What's your next base? What are you multiplying? Very good. So your final answer, negative 32, x to the y to the 15th. Oh, yesterday we added. Should I add 5 and 15? Why not? Not the same base. Not the same base. Okay. Let's go. Let's skip this one. Go to this guy. What am I doing here? Yeah, this is yesterday, right? We don't have any powers stacked on powers. We just have a bunch of variables right next to one another, aka multiplication. Remind me from yesterday, what do we do with this? You add. We got to regroup them though, right? What's the first base I could put together? X to the and x to the 4th. And my next base. Y to the and y to the and my last base to the and z to the. Technically there's no other one, right? So really just a z to the 8th. Okay? So as we keep our base, keep your base, which is, ignore them. Keep your base, which is x. What are you doing to your exponents? Add 2 plus 4. Keep your next base. What's your next base? Y, and go 4 plus 1. Keep your next base. Z. Oh, okay. Z to the 8th. Yep. So my final answer, x to the 6th, y to the z to the 8th. Can I add them together? No. Good so far? I say let's skip the bottom left if you're cool with it. You cool with it? Let's go to the bottom right. We got a mess here, don't we? I think I should do first. Jackson? That's exactly what I would do. Okay, I'm not going to touch this very inside here. I'm going to simplify this down to one exponent as much as I can. Okay, 3 times 2. Okay, so I'm going to keep negative 2g to the 4th h, and really it's going to be to the 3 times 2, or in other words, to the 6th power. Now this isn't so scary, agreed? What do you got to do with that 6th power, though? Distribute it all out there. So negative 2 needs the 6th, g to the 4th needs the 6th, and h needs the 6th. Is my answer positive or negative? Positive, because there's 6 negatives. Now, when we took 2 to the 5th, we had 32, so take one more 2, you'd end up with 64. What are you going to do to your exponents on g? Multiply. How about your exponent on h? 1 times 6. So you end up as a final answer of 64, g to the 24th, h to the... All right, you ready? Oh, Nellies. How do I even approach this? Jackson got us out of a bind in the last one, and he told us to multiply those 2 outside exponents, which I thought was fantastic. Okay, but this just got way more intense. Does everybody see we really have 2 chunks multiplied together? Okay, so you really have like this piece here, and whatever the answer to that is, multiplied by this piece. Follow me? So if we really just calculated each of those separately and then as our very last step multiplied them together, we should be good. Agreed? Okay, so let's just take the yellow one. That 3 on the outside has to be shared with everything on the inside. So -7 gets the third, A gets the third, B to the fourth gets the third, and C gets the third. I will tell you, I would not put negatives, bless you, and exponents into your calculator. In my mind, I have 3 negatives. Is my answer positive or negative? Negative. Could I put 7 to the third in my calculator? 100%. Okay? But the negative part, the calculator is only as smart as the input operator, so it doesn't always know. It only does what you put in there. What is 7 to the third?
14 times 7.
Not 14. Should be 343, right?
Yeah.
So is it positive or negative? Negative 343. What exponents am I multiplying on A? B, 4 times 3, and C, 1 times 3. So the yellow side, simplified as far as we can, should be 343, A to the third, B to the C to the third. Okay? Now take the blue side. What should I do first? I would multiply that 2 and 3. So I really have 2A squared C, and then 2 times 3, which is really 6. Now that 6 has to share inside, yes? 2 to the 6th, A squared to the 6th, C to the 6th. 2 to the 6th? 64. What am I multiplying on A? 2 times 6. And on C? 1 times 6. So I end up with 64, A to the 12th, C to the 6th. Now I'm going to put that in parentheses just so I remember that's one chunk. And then I'm going to drag down my negative 343, A cubed, B to the 12th, C cubed. Because those were our 2 separate pieces that we're really looking to multiply. Okay, so everything up above that I'm covering now was today's. Now we got to jump back to yesterday's. Regroup things that go together. What's the first 2 things that you should regroup together? Negative 343 times 64. Then what are you going to group together? A to the third times A to the 12th. Then nothing to go with B to the 12th. Okay. Then C to the third and C to the 6th. And when I'm multiplying, what am I actually doing to those exponents? I'm adding them. Okay, negative 343 times 64. Negative 21,952. Anybody else? I stole that off of Alyssa's calculator. Did you guys get that? A to the 15th, B to the C to the... Oh, yeah, I wrote 16 there instead of 6. I'm like, where are you getting that? To the 9th? Jackson.
Will we ever get to the point this year where they're going to give us a substitute for A, B, or C and just to solve it?
That's actually less complicated than what you're doing. That's just substitution in order of operations. Last Friday, you did. Questions? Go to work.